So good morning children. So last class we have completed 3 lessons. Okay, today we are going to start the new lesson. Okay, fourth lesson. Okay, that is lesson number 2, motion. Okay, so first one, introduction about motion. So what is mean by motion? So already we have learned from 7th standard and 8th standard about motion. Okay, first we will see the definition about motion. Okay, so if you are taking one example, birds and animals. Okay, look at these examples. Okay, so what is the definition about motion? So if an object change their position, position. Okay, if an object change their position with respect to time, okay, that is called motion. Okay, so birds will not sit in one place. Okay, often it will change their place with respect to time. Okay, so that is called a definition about motion. Okay, second one, rest or stationary. Okay, if an object does not change their position with respect to time, it is called rest or stationary. For example, a pencil, okay, eraser. Okay, so these are all the examples about rest or stationary. So if you are keeping pencil or eraser on the table, okay, it will not change their position with respect to time. Okay, if you are keeping today 8 o'clock, the tomorrow morning 8 o'clock you may see also the same way what we kept on the table, the same way it will be there. So that is the definition for what? Rest or stationary. Okay, so motion is nothing but what? If an object change their position with respect to time. Rest or stationary if an object does not change their position with respect to time. Okay, it is called rest or stationary. Okay, next one, types of motion. Next one, types of motion. So first one, linear motion. Second one, circular motion. Third one, oscillatory motion. Fourth one, random motion. Okay, so types of motion, 4 types are given in our textbook. Okay, first one, linear motion. Second one, circular motion. Third one, oscillatory motion. Fourth one, random motion. So what is meant by linear motion? What is meant by linear motion? So motion along a straight line. Either the horizontal position or vertical position. Okay, so if you are seeing the lift, okay, it is moving up and down. Okay, so what position? Vertical position. So the type of motions are the examples of linear motion. Second one, circular motion. Motion along a circular path. Okay, third one, oscillatory motion. Okay, repetitive to fro and motion of an object at regular interval of time. Okay, okay, that is called oscillatory motion. Fourth one, random motion. Motion of the object which does not fall under any category. So it is called random motion. So random motions will say, okay, all the motions it will come are apart from that. Okay, that is the definition for random motions. Okay, so next one, uniform and non-uniform motion. Uniform and non-uniform motion, uniform and non-uniform motion. Okay, so what is the meaning about uniform and what is the meaning about non-uniform? Okay, so if an object, okay, if an object covers a particular distance in particular time, in a particular time, okay, that is called uniform. Okay, so non-uniform means, okay, it will cover different distance in different time. It is called non-uniform motions. For example, okay, if an object covers 60 kilometer in 1 hour, 60 kilometer in 1 hour, the same way the same object covers 120 kilometer in 2 hours. Okay, so equal distance, equal distance. So non-uniform speed is nothing but, okay, non-uniform speed is nothing but, okay, the same object it covers, okay, first 1 hour 50 kilometer, okay, second 1 hour the remaining kilometers means how many? 120 plus 60, 180, okay, already 50 over 130 kilometer. Okay, so first hour covers only 50 kilometer, second hour it covers 130 kilometer. So this is an example of non-uniform speed. Okay, so uniform and non-uniform speed or motion. Okay, so next one, distance. Next one, the distance, about definitions. Okay, the actual path of the ray traveled by a moving body irrespective the direction of any position is called a distance. Okay, so for example, if you are taking any one of the object A, it will start, okay, it will reach the point B, it will move in any direction, okay, any direction, okay, that is called distance. Okay, any direction, that is called distance. Okay, what is the SI unit of distance? Okay, SI unit of distance is meter. Okay, there is no directions, okay, it will move in any directions. Okay, so there is no particular direction. So that is the definition for distance. Okay, in short way also we will define the distance is nothing but what? The shortest distance between 2 points. Okay, the shortest distance between 2 points A and B. Okay, this is called a distance. Okay, next one, displacement. Second one, displacement. So displacement is nothing but, okay, the distance between 2 points in a particular directions, Okay, suppose if you are taking example A, B, okay, so particular directions means what? In this direction. Okay, the shortest distance between 2 points in a particular direction, so that is called a displacement. Okay, so we can move in this direction also, we can move in this direction also. So which one is the shortest distance from A to B? So this only shortest distance, not for this, not for this. So what is the definition for displacement? Okay, it is the shortest distance between 2 points, okay, A and B in a particular directions. Okay, what is the SI unit of displacement? So meter. Okay, so next one, speed. Next one, speed. So speed is equal to distance divided by time. Okay, so speed is equal to what? Okay, what is the definition for speed? Speed is the rate of change of distance or the distance traveled in unit time. Okay, so speed is equal to distance. Usually we will measure either kilometer or meter. Okay, the same way time, Okay, so big unit means a kilometer means hour, meter means a second. Okay, so either kilometer per hour or meter per seconds. Okay, this is the SI unit of speed. So speed is nothing but what? Distance divided by time. Okay, suppose if in any problem, if you are seeing in our textbook, okay, either two values given, either speed value or distance or time value is given, we have to find out the another one value. Okay, so next one, velocity. Next one, velocity. So what is the difference between speed and velocity? Okay, next one, velocity. So velocity is nothing but, okay, change of displacement. Change of displacement divided by time taken. Divided by time taken. Okay, so why here we have taken the change of displacement? Change of displacement. Okay, so displacement, it has what? Particular directions. Okay, the same way SI unit for velocity, meter per second, or in this way also you will write meter n or minus 1. Okay, both also correct. Okay, so what is the main difference between speed and velocity? Speed has, there is no direction. Okay, no direction, no direction, but velocity it has what? Direction. Okay, this is the main difference between speed and velocity. Speed has no direction, but velocity has directions. Okay, next one, acceleration. Next one, acceleration. So what is mean by acceleration? So acceleration is nothing but change of velocity with respect to time is called acceleration. Okay, so change of velocity, change of velocity divided by time taken. Okay, change of velocity already we know, meter per second. Again time taken second, so meter per second into 1 by s is equal to meter per second square, or meter s power minus 2, meter s power minus 2. Okay, so how to define the definition about acceleration? Change of velocity with respect to time, that is called acceleration. What is the SI unit of acceleration? Meter per second. Okay, divided by time taken second. So m divided by s into 1 divided by s. So m divided by s square, or m s power minus 2. Okay, so the in this heading, okay, suppose the value is negative. Suppose the value is negative. Okay, that is called negative acceleration or retardation or deceleration. Okay, suppose the negative acceleration value minus 2 meter power. Okay, this value is given. Okay, actually the acceleration value is minus 2 meter second power minus 2. Okay, so we will write in this way also, negative acceleration. Negative acceleration is equal to, so negative means automatically we will remove the negative sign. So 2 meter second power minus 2. Okay, so next one, okay, distance time graph. Distance time graph based on the uniform motion. Okay, uniform motion. Distance time graph. Okay, so x axis, y axis, here we have to take time, here distance. Okay, so here we have to mark 5, 10, 15, 20, the same way here 5, 10, 15, 20. Okay, for uniform motion, okay, 5 minutes it will cover only 5 kilometer, 10 minutes it will cover 10 kilometer, 15 minutes it will cover 15 kilometer, 20 minutes it will cover 20 kilometers. Okay, that type of motion is called uniform motion. So uniform motions means we will get one straight line, we will get one straight line. We will get one straight line for uniform motion. Okay, so non-uniform motion, okay, so first 5 minutes it will cover 10 kilometer also, okay, 10 kilometer also. Okay, second 10 minutes it will cover only 5 minutes, 5 this kilometer also. So automatically the graph it will come in this directions, okay, zigzag direction it will come. Okay, that is called non-uniform motions. Okay, these things we will see in briefly in the next class. Okay, so today class up to we have discussed about what now, up to the distance diagram for uniform and non-uniform motions. So today homework is, okay, in this lesson, okay, so activity 3 and problem 1 and 2, okay, activity 3 problem 1 and 2, okay, page number 16, okay, in your textbook. Okay, the questions is given, you have to find out the answer for these questions. Okay, so thank you children, we will see in the remaining part, we will see in the next class. Okay, thank you.